All right, so I explained in a previous video why there are no reported electronegativity values for argon, neon, and helium. But sometime in the future, you could imagine electric negativity values being calculated. After all, we have a blueprint that Pauling gave us for how to do this, right? We just need to compare it to some standards that contain that element, for example, with hydrogen. So because you can measure this, at least theoretically, as long as you have some compounds of this made, and as long as those compounds are under the same conditions. So let's say in the future, um, a bunch of formal helium compounds are made under probably very, very high pressures. You could get back out electronegativity values for helium. And so what I wanted to think about in this video is just, what would the electronegativity value of helium be, and neon and argon? Well, we know there's this trend that as you move to the right on the periodic table, you move higher on the periodic table, you have greater and greater electronegativity. So that's why fluorine's right around 4. It's the most electronegative element known. But based on this, helium should have an even higher electronegativity value. So, I was curious, what do we think this electronegativity value would be? And so I did some very simple calculations just based on periodic trends. So here's an Excel spreadsheet where I just took these values from Wikipedia of the electronegativities, and I looked, across each period, what the trends are. Okay, so you can see this is starting from 0.98. So what is that? That's lithium, going lithium and marching across the periodic table, the S and the P blocks, to fluorine at 3.98, and it gets like this. I mean, it's pretty much a straight line. That's really close to a straight line. And you can do this with, the other periods, and then things get a little messier, but still pretty much a straight line, right? So and then we can do that also with period 4. Period 4 has argon in it, and you can see what sort of happens when it has krypton in it, which has an electronegativity 3. You can see krypton has a pretty similar electronegativity as bromine. Xenon is actually a little bit less, but pretty similar to iodine, and radon and astatine are estimated to be the same. So it seems like they're fairly close to their corresponding halogen. Okay, so perhaps then, first order approximation, we expect argon to be around 3.2, similar to chlorine. Neon, we probably expect to be around 4, similar to fluorine. That's forcing helium to be higher, right? If we're to have this trend. So helium should be higher than 4. So how can we predict, how high this would be? And so, I put these values 3.2 and 4 in, and then I also looked at, so that's considering this trend going left to right. I also looked at the trend going up family, right? And so you can look at this trend. Okay, so like here is the halogens, and there's fluorine, and you can see it kind of really jumps, okay, when you get to fluorine. Fluorine is just really electronegative. Here is the chalcogens, okay, and again, you see this jump when you get to when you get to oxygen. There's really a kind of a jump there. And then here are the finctogens, so this is nitrogen, and so I did all these, okay, and yeah, you can see if you take the slope of this line, and you do all this, what you'll see is that, at least starting from the carbon group, okay, the slope it increases as you go to the right. And so from that, you can kind of predict, if you take the slope of the slopes, you can kind of predict what the slope should be, and then put in a number for helium that matches that slope, okay? And so if you do all that, or I did all that, and the value I got was 4.3. So I predict the electronegativity of helium, if you're able to make compounds of it someday under super, super high pressure or something like that, or under some other exotic conditions, I predict that we will calculate that the electronegativity of helium is about 4.3, neon about 4, argon 3.2. Those are my predictions based on periodic trends. So I'm just channeling my inner Mendeleev here, right? But it kind of makes sense. Helium should want electrons more than any other element. And so strictly speaking, helium in some sense is the most electronegative element. If you Google that, they're going to say fluorine, because we don't know what the electronegativity of helium is. But all signs point to that helium should be the most electronegative element. And by my calculations, the electronegativity should be 4.3. I don't know if anybody's ever made that prediction before. I can't seem to find it anywhere, but let's see. Maybe, several years from now, we'll see something come up with it.